alaikum wa rahmatullahi wa barakatuh. Today I will be explaining optical fiber. So without any further ado, let's get started. Okay, I would like to introduce myself. My name is Yazan Iyad. Okay, so in this presentation I'll be explaining the history and definition of optical fiber. I'll be explaining how it works. I will also mention the types of optical fiber, and I will also mention the uses and applications of optical fiber, manufacturing, how is it made, and lastly I will be talking about advantages and disadvantages of optical fiber. Okay, optical fiber. History and definition. Fiber optics or optical fiber refers to the medium and technology associated with the transmission of information as light pulses along a glass or plastic strand or fiber. Fiber optics is used for long distance and high performance data network. Fiber optic cables are used as they hold a number of advantages over copper cables, such as higher bandwidth and transmit speeds. History. A brief history of fiber optic communications. Optical communication systems date back to the 1790s to the optical semaphore telegraph invented by French inventor Claude Check. In 1880, Alexander Graham Bell patented an optical telephone system, which he called the photophore. Principle of operation. So how it works. So the concept of how it works is that fiber optics transmit data in the form of light particles or photons that pulse through a fiber optic cable. The glass fiber core and the cladding each have a different refractive index that bends incoming light at a certain angle, as you can see in the picture. When light signals are sent through the fiber optic cable, they reflect off the core and cladding in a series of zigzag bounces, adhering to a process called total internal reflection. The light signals do not travel at the speed of light because the denser glass layers instead traveling about 30% slower than the speed of light. So because the glass is dense and has layers, instead of traveling at the speed of light, it travels at 30% slower than the speed of light. Okay, that's because of the denser glass layers. Okay, so to renew or boost the signal throughout its journey, fiber optics transmission sometimes requires repeaters at distant intervals to regenerate the optical signal by converting it to an electrical signal, processing that electrical signal and retransmitting the optical signal. Fiber optic cables are moving towards supporting up to 10 gigabytes per second. Typically, as the bandwidth capacity of a fiber optic cable increases, the more expensive it becomes too. Okay, so types of fiber optic cables. Multi-mode fiber and single-mode fiber are the two primary types of fiber optic cable. Single-mode fiber is used for long distances due to the smaller diameter of the glass fiber core, which lessens the possibility for attenuation. Attenuation is the reduction in signal strength, if you don't know the meaning. The smaller opening isolates the light into a single beam, which offers a more direct route and allows the signal to travel longer distance. Single-mode fiber also has considerably higher bandwidth than multi-mode fiber. The light source used for single-mode fiber is typically laser light. Single-mode fiber is usually more expensive since it requires precise calculations to produce the laser light in a smaller opening. So here's a picture of what I was saying before, look how small the opening is and the cladding which sticks the glass. Okay, types of optic cables. Multi-mode fiber. Multi-mode fiber is used for shorter distances because the larger core, its larger opening, allows light signals to bounce and reflect more along the way. So it's larger side where the beam comes from, it's larger, and so it allows light signals to bounce and reflect more along the way. The larger diameter permits multiple light pulses to be sent through the cable at one time, which results in more data transmission, so you can have more files than in single mode fiber. So this also means that there is more possibility for signal loss, reduction, or interference. However, multi-mode fiber optics typically use wild copper wire cables, where the traditional choice for telecommunication, networking, and cable connections for years. Fiber optics has become a common alternative. Most telephone company long-distance lines are now made of fiber optic cables. Optical fiber carries more information than conventional copper wire due to its higher bandwidth and faster speeds. Because glass does not conduct electricity, fiber optics is not subject to electromagnetic interference, and signal losses are minimized. So here's a picture of the core. So you can see in single mode, multi-mode, and OM1 multi-mode. You can see the diameters, how they differ apart. Okay, uses and applications. I'll be talking where we use these things, where we use optical fiber. Okay, computer networking is a common fiber optics, like we use internet now while I'm explaining the video. Fiber optics use case due to optical fiber's ability to transmit data and provide high bandwidth. Similarly, fiber optics is frequently used in broadcasting and electronics to provide better connections and performance. Internet and cable television are two of more commonly found usages of fiber optics. Fiber optics can be installed to support long-distance connections between computer networks in different locations. Military and space industries also make use of optical fiber as a means of communication and signal transfer. In addition to its ability to provide temperature sensing, fiber optic cables can be beneficial due to their lighter weight and smaller size. Fiber optics is frequently used in a variety of medical instruments to provide precise illumination. It also increasingly enables biomedical sensors that aid in minimally invasive medical procedures. Because optical fiber is not subject to electromagnetic interference, it is ideal for various tests like MRI scans. Other medical applications for fiber optics include X-ray, imaging, endoscopy, light therapy, and surgical microscopy. Okay, so now we'll be talking how it's made and its manufacturing. An optical fiber is manufactured from silicon dioxide by either of two methods. The first, the crucible method, in which powdered silica is melted, uses fatter, multimode fibers suitable for short distance transmission of many light waves. So as I said before, multimode fibers are thicker in size in compared to single mode fiber. Okay, so now I'll be talking about its advantages and disadvantages. Fiber optic cables are used mainly for their advantages over copper cables. Advantages include support of higher bandwidth capacities. Light can travel further without need as much of a signal boost. They are less susceptible to interference such as electromagnetic interference. They can be submerged in water. Fiber optics are used in more at-risk environments like undersea cables. And also, fiber optic cables are stronger, thinner, and lighter than copper wire cables. They do not need to be maintained or replaced as frequently. However, it is important to know that fiber optics do have disadvantages that users should know about. These disadvantages include copper wire is often cheaper than fiber optics. Glass fiber requires more protection within an outer cable than copper. Installing new cabling is labor intensive. Fiber optic cables are often more fragile. For example, the fibers can be broken or a signal can be lost if the cable is bent or curved around the radius of a few centimeters. Thanks for watching. Now you know about optical fiber, or you know more about optical fiber. I hope you liked the video, and salam.